Okay, let's focus. What did I say at the end of last class on Wednesday that we needed to do with this?
That y equals x little line.
So we do need to do that. What kind of function is this? Say that again. Yeah, very good. It's a piecewise function. So if it is a piecewise function, how many parts do I need?
Dos.
Yeah, you can write it with 3 if you want to write it with 4.
Why did you say you could write it with 3?
Well, because that little part can be written as an absolute value equation.
Do they have the same slopes?
Oh, ever so slightly different.
Right? Yeah, this one goes here, and this one just goes here and here. So they look really similar. Good eye for that. But because the slopes are different, we got to go with a 4th. Ah!
Ew. Disgusting. That is too many.
It's not. It's going to be awesome. Okay. How do we set up a piecewise function?
You have the f of x and then the weird little squiggly brackets.
Yes. F of x is equal to, and the squiggle bracket. And we know that we have 4 different pieces, so let's start with the first one. What do we need first? Or actually, before we even look at any of the functions, what do we need first?
The intervals?
Yeah, the domain intervals, right? So this first one, where does it look like it's going?
Let's go with
infinity.
Yeah.
Positive or negative?
Negative infinity.
Looks to me like it's going to negative infinity. They don't have a little arrow here, but we could assume that. If you really, really were like, no arrow, we're not doing it, then I would be like, all right, chill, but that's fine. We could do -8 to 2, -2. But I like negative infinity. So let's go ahead and write the domain over here. Interval of this first one. -8 is less than, x is less than or equal to -2. Now we need the next domain. So what is the next domain? -2 to 2. 2 to 2 to 2. Hey, we are focusing right now, Tayson. That's what. Okay, the third interval. Jacob. 2 to 4. Do we have concurrence? I'm not checking these right now. I will in a second, but do we have concurrence on that?
Yeah.
Okay, great. And the third and final interval.
4 to infinity, yeah.
And beyond. Very good.
No.
Not beyond.
No.
Yeah. Why not? Because infinity is what?
An idea.
An idea, not fault. What?
False.
No, it's an
I wrote that
idea.
down.
Excelente.
False.
Infinity is an idea, not a number. So you can have degrees of infinity. That would technically be beyond. That means a power of infinity when you multiply two infinities. But if you just add infinities, they just go. It's like a big blob that absorbs everything. Okay, so we have our 4 intervals. What do we need next?
We need the ranges.
Did you say derange or the ranges?
Deranged.
Deranges. Do we need the ranges though?
The Rock Johnson.
It's
We-
Rock the Dwayne.
We do not focus. Do we need the ranges? Jacob said no.
No.
Or no, the functions.
We need the function. No, you're good.
Wrong word.
You're good.
What's your function? Conjunction, junction.
So for this first one on the left-hand side, what would the function be for this?
Y equals 1/2 x.
Yeah, so it's got a rise of 1 and a run of 2. So it's rise over run, so it's 1/2 x. And if we continued this line on, so we go up 1 and over 2, where does it cross the y-axis?
0.
0. So do we need to include that as our y-intercept? Nah, it's just 1/2 x.
Yay.
E.
A.
Oh.
It's in the game. All right.
It's not in the game.
Then the middle function, or the first middle function.
That's 3/2 of x.
Oh, very nice. Because why?
Because them slope and then them intercept.
Them slope and them intercept. Yes, the slope and the intercept. Right? The slope is positive 3 rise over a run of 2. And the y-intercept is 2. 3/2 x plus 2. No.
Not again.
No.
You guys, why does it do that? Well, this is where we were at. Oh my gosh. 3 halves x plus
So-
2. You guys had everything else written down already,
No.
right? What else didn't you
I'm
have written
weird. I
down?
don't write the function before the domain. I just cry.
So you didn't have any of the domains written down.
I have one now. I
Okay,
have the
well,
second
good
one.
luck on the other 3.
I got it.
I know that you can do them, so you'll be good. If you do have questions along the way, ask me. We'll talk about it. Ask me. We'll talk about it, and we'll be
Please
good.
do not murder Mr.
Okay, please. I second that statement. Okay, this third function now, this downward sloping one. What is its slope? I gave you a hint in that it is downward sloping.
1/2
Ooh.
plus 6
Since it's downward, it needs to be negative 1/2. So
plus 9.
a rise of negative 2 and a run of 1. So that's negative 1/2. And then if we were to go up 2 and back 1, it would be to 7. And then, yep, it would be plus 9. So negative 1/2 x plus 9. Also, I will post, Hadassah, I'll also post this to the interwebs.
They will be
Good,
there before
good,
it
good.
deleted at all.
What?
Will be there.
You'll see them before they were deleted.
Yep.
That video will last longer than you do, probably.
That's
No
sad
sassy.
and dark. Finally, the last one. What is this slope?
That's the funny thing about slope.
Is it just 1?
0.
It's 0x, so anything times 0 is 0, so we do not need to include that. But what would the y-intercept be?
1.
1, so all we got to do is just say 1. There we go. All right, now let's talk about the other parts of this question. Let's see, I got to open them up. What is B?
Oh, does this mean we have to write
Domain
all of
and
the domains and ranges for like?
So that's a good question.
Because like if you want to.
We said the intervals of specific functions of this piecewise function, right? But what is the domain of the entire function?
It's
Infinity,
infinity to
negative
infinity.
infinity.
Negative.
Very good. That's the entire domain. It's just all the way from negative infinity all the way to positive infinity. So we can say that B, our domain, is negative infinity to positive infinity.
Isn't that the same for the... Oh, wait.
No, because
No.
there's a maximum.
The maximum.
Ooh, so we see that it does go toward negative infinity on the left-hand side on the y-axis. But up here, it's capped out, yeah? And down here, this doesn't increase at all. It's just going to the right, right? So it increases on the x-axis, but not the y. So what's our range's
Is it?
top? Or what is our range?
5.
To 5. Yeah, very good. And we'll go ahead and put a bracket because it does look like it equals 5. Sorry, Sam.
No, I think it's the interval.
Wait, go back.
Oh, did you do the interval note like the other notation? That's fine if you did that. Just make sure that you put a y in. It's too
Yeah, that's
late.
what I
Oh,
did. It's too late now.
nice. Hmm.
Well, there's a definite
No.
y intercept. There's
Oh yeah, the next one.
there's technically an x intercept. That's probably like
Yeah.
negative 1.5 ish.
Thinking point
One,
4.
one and a quarter.
Yeah.
I could make you guys actually solve for it.
No.
It can't.
That actually sounds interesting.
Okay, let's see how we could solve for it. Let's see how we could solve for it.
No.
Which part of the function is it?
Easy.
Which part of the function is it? I want to show you guys how simple it is. It's the second one, right? We're going to take that for a second.
And solve for x.
What is y equal to when we are touching the x-axis?
0.
0. So if we were to say y equals 3 halves x plus 2, we could just say 0 is equal to 3 halves x plus 2. So we need to solve for x. So I'm going to subtract 2 from both sides. And I get negative 2 is equal to 3 halves x. What do I need to do to 3 halves x?
Reciprocal.
Multiply by the reciprocal. Beautiful. So negative 4/3 is equal to x. Look at that.
Wait, let's see
So
if
it's-
it was right, if we were like,
1 point.
one.
No.
It would be 1.3, negative 1.33333
Are you
repeating.
sure?
Positive.
1 1/3.
But thank you for asking. I do appreciate you checking me. So we were close, but we can actually find those intercepts, right? And this is even an exact intercept too. It's not even an estimation. It is exact, and I'm here for it. What about the y-intercept?
That's just,
Trois.
yeah.
3 is 3.
No, trois.
Deux is 2. 3 is 3.
Well, because
Un,
it's trois.
deux, un, deux, trois, quatre,
1, 2, 3, 4, 5.
Yeah, I don't know that language.
It's French. So y is deux.
I just invented a
Two.
new word that already exists.
You did, and you invented it wrong though.
wrong.
Oh
Is that
man.
even possible? If you're inventing something, how can you invent it wrong?
Yes.
That you could just
And
say
I-
that's how
I
it's meant
actually
to be
have a claim
invented.
For this.
We will talk about that later once we are done with the lessons, okay?
Yeah.
So what about letter D, the location and value of maxima and minima?
That's gonna be.
There be no minimum, but there be
There's
maximum.
both.
Is there? Are there?
No, because
No.
the minima is just.
Look at the arrow.
It's just
Goes down forever. So there's no minimum because you can't have a minimum at negative infinity. Why can't you have a minimum at negative infinity?
Idea.
Because it's an idea, not a number.
false.
You could pick any number you want, and there will always be a number that is more negative than that number.
7.
Yep, 6, more negative. Boom, prove it. Well, it's not proven, but you know, it's an example. Okay, what about maxima? Or a maximum?
It's maxima and it's 5.
Ah, is it maxima or maximum?
It's maxima because maxima's Latin and Latin's better.
They're both actually from Latin.
Well, they're from Latin, but maxima is Latin.
Latin.
So maxima is actually plural. Latin plural. And maximum is singular. So, is it maxima or maximum?
Maximum.
Maximum. Mum's the word. So, we have our maximum. You know what?
Mom.
Because it is singular, there's just the one. And where is that maximum located?
5.
2, 5.
Yeah, let's have a greater level of specificity. So we're going to be at 2, 5. I could have just gone, let's be more specific there, but specificity is so much more fun of a word. That's not French.
Specificity.
Hard as mine.
It's the specificity.
That does not.
All right, anyway.
Kind of fits.
No.
Eve, bare necessities.
I was like, no.
Sounds like what?
Wait, what's the actual lyric?
Yeah, it is.
What?
No, I know.
No, it's specificity in the movie.
Okay, I
They
thought that
definitely
had the
say.
increasing
Yeah, they
and-
All right, intervals where the function is increasing. Hadassah, lay it on us. What is it?
So it's increasing, and you're gonna write like so it's negative infinity.
Mm-hmm.
The less than.
Yeah.
That's right.
That's
X
right.
Less than or greater to 5.
Less than or equal to.
Equal to.
And you're super, super close. It's 5 on the y-axis, but we always deal with these as intervals of domain.
Yeah, so 2.
Yes, very good. Less than or equal to 2. Oh my gosh, that's
If
great.
that is the case, the decreasing is 2 less than or equal to x less than or equal to. Where is that? 4.
Very
And
good.
then it's
constant.
I'm getting there.
Okay.
It's
I also
4 less than or equal to x is less than infinity, right?
good. Yes. Now I'm going to just make one slight correction. This and this, I'm going to have only as less than instead of less than or equal to, because the less than or equal to is already obtained or like used on the
Oh,
previous
yeah.
one.
I forgot about that.
You can't all, or like, is it?
No, 'cause that-
No, because you
Yeah,
can't have a
that
function
rule
that's
is-
increasing and decreasing at the same time on those points. So what we do is we say that it's only increasing to that point, and then it starts decreasing right after that point. You could also do it the other way. You could say is less than 2, and then 2 is less than or equal to x is less than or equal to 4 if you wanted. But the way that the kind of convention that we have used in this class is do it on the first side, and the second side is just less than. So like the second time we hit that value is just less than instead of less than or equal to.
So if we were to accidentally do that on test, would you just take off like half a point,
You know, I probably wouldn't even take off a point. I would, because it's more of a formality than a matter of correctness, you know? So I want us to be thinking about it mathematically, but I'm just going to say like, hey, you need to just be cognizant of this. It's not the most wrong thing that you could do, you know?
Okay, but Mr. Bro, wouldn't it be incorrect because a function can only have one singular point for each like destination, and if the two separate functions each have a point there, multiple points for that one.
Yeah, actually, you're right. It would be. Because then it would no longer be a point because one, or a function because the function would have 2 y values for that x value. Tayson's right. I'm taking off a half point if you do it.
Let's go.
Let's go. And there was much rejoicing. No, you're Hadassah.
That was just bad.
I'm sorry. No, I'm Mr. Ball. Okay. Let's go ahead on to 4.8, the lesson.
There's not a full
Not a
day.
4.8.
Whoa! Good
I
thing.
can't wait to hear what that sounds like on the recording.
Well, then, actually, here, we'll go ahead and end this recording and just say.
Post it, we can slow it down.
It'll sound like Wario. 9 through. No. You guys are meant to do that on your own. Remember?
Scary.
That's. Oh, look, I'm pausing it. This is still on the recording. Oh, that's right. Not his homework, but I am putting this on the recording.
Okay.
So now I want you to go in and fill that out from the recording. All right, and
W.
we are done in 3, 2.